Hello guys, we are back again, continuing with the calculus optimization problems. Okay, so in the previous live video or live stream, we stopped right here with this question. So we were doing this question, so we're pretty much done with it because all that was left, it was to firstly obtain all the like terms here and add them together. So we have x to the power of -3, and then we've got negative x squared minus 3x squared. So that would be minus 4x squared. And then we have minus 5x plus 2x. So that would be minus 3x, right? And then we've got minus 3 plus 5, which would be plus 2. Yeah, that would be plus 2. And by the way, in case you do not know which live stream I am talking about, it's exactly the previous live stream to this one, and I was doing it few hours ago today. So do check it out. If you are watching this, later on, I will have linked it in the description, and it will also appear on the screen, so you'll be able to click on it. All right, so here is the equation for v after combining all the like terms, and now we can work out the first derivative. So it's 3x squared minus 8x, right, minus 3. Okay, and then here, this is the equation that we can solve. Of course, now we need to set this to 0 because we are optimizing here. So what I'm gonna do is I'll just use the quadratic formula, but I'm not gonna write it down. But remember that you do need to do that in the exam. So yep, so we'll have minus b. Our b is -8 plus the square root of -b squared. So -8 squared minus 4a, which is 3, and c, which is -3. Okay, what's happening here? Okay, oh, okay. So -8 squared, right? Minus, hey, I don't know what happened here. So -b squared minus 4a, which is 3, and then multiplied by c, which is -3. Okay, all divided by 2 into a. Again, a is 3. Okay, so we get x equals to 3. So x equals to 3. I hope that I inputted everything in the calculator correctly. Let me just double check. So yeah, the denominator is fine. And then 4ac, 4 into 3 into -3. Okay. And okay, yeah, all looks good. Now let's see the second value. It's -1 over 3. -1 over 3. Let's turn that calculator off. And well, yeah, now we were told here that the interval is from -1 up to 0. So the x value that is within this interval is this one, right? So I'll just say x is not equal to 3. This is our x value here. We can even conclude here that therefore x equals to -1 over 3. And now we are not done because we do not only want to find the x value that will give us the maximum vertical distance, but we want to determine that maximum vertical distance. So the last thing to do is to sub this into the original equation. So I had already explained all what I am doing right now in the previous video, right? So that's all that you gotta do now. This is your simplified equation. So we'll have negative 1 over 3 cubed minus 4 into negative 1 over 3 all squared minus 3 into negative 1 over 3 plus 2. So you just need to punch all of this into your calculator and get the answer, which is going to be the final answer to this question. Okay, after finding whatever that value is here, I would advise that you just make another conclusion that therefore the maximum vertical distance, and then just write what the value is that you get here after substituting in negative 1 over 3. So let us not spend waste any more time here and just move on to another question. So now I just wanted us to begin with this one, and I think there's also another kind of similar question to that. And here it is. It's from the May-June 2021. So even here, I'm saying it's similar because what I noticed is that they kind of, yeah, you see we've got a cubic polynomial here. So it's kind of under the same question as this optimization problem. Let's actually see whether what is going on here. Otherwise, here, as you can see, it's question 8. And again, just pause and observe this is some observe if this is something that you'd be able to do by yourself. I mean, you should make sure that you get these marks, guys. First principle, and using the differentiation rules. I mean, you should be able to do that. Make sure that you take all of those marks. Otherwise, let's quickly see whether what is actually happening here. Although this is still not, exactly an optimization problem. So we've got a graph of f of x equals to ax cubed plus bx squared plus cx plus d. And we are told that it has two turning points. The following information about f is also given. We are told that f of 2, therefore if x is equal to 2, f will be equal to 0. Okay, so what is this? Because um, the x value is 2, but f is equal to 0. Therefore, the corresponding y value is 0. So this is an x-intercept. You need to note that here we actually have an x-intercept. They are giving us an x-intercept. And then they say the x-axis is a tangent to the graph of f at x equals to -1. Very interesting. So the x-axis themselves, they form a tangent to the graph of f at x is equal to -1. How can that be the case? For me, I think the x-axis can only be a tangent to the graph if you've got something similar to this. Let's quickly go back here. So you see here on this polynomial, indeed the x-axis here did form a tangent to m. You see, this is an example of what they are talking about. So if the x-axis are a tangent to your cubic polynomial, it means that at that point you've got a turning point, right, as well as your x-intercept. So we've got something similar to this in the function that they are telling us about here. So we've got a similar scenario. So x equals to -1 must be both a turning point and x-intercept, which then makes sense. And again, for those who have watched the previous video, this is gonna make much more sense, because another piece of information here is that this has two turning points. So indeed, this cubic polynomial they are telling us about is similar to that one we were seeing, in the previous live stream. Okay. And now what else here? We are told that the first derivative is equal to 0, at x is equal to 1. So this is another turning point because the x value where the turning point is equal to 0 is a turning point. So x is equal to 1 is another turning point here because it means in the first derivative of f, if you make x equals to 1, you get 0. So the gradient is 0 where at the turning point. So it means that x is equal to 1 is a turning point. So that's the second turning point here. And then we are told that f prime of 1 over 2 is greater than 0. So the first derivative when x is 1 over 2 is positive. So it means that we can interpret this one as follows. It means that at x equals to 1 over 2, f is increasing. That's what it means if a gradient or the first derivative at a point is positive. It means that f is increasing. So this is quite an interesting question. They say without calculating the equation of f, use this information to draw a sketch graph of f, only indicating the x coordinates of the x-intercepts and the turning points. Wow, very interesting question. So let us draw the Cartesian plane and use our interpretation of the information given here to sketch this graph. Okay, so here the yeah, here's our Cartesian plane. Those are our y-axis and these are our x-axis. So we've got an x-intercept at x equals to 2. So this is x-intercept at x is equal to 2 because if x is equal to 2 on the graph of f, the corresponding y value is 0. So let's say 2 is here. Let's say this is here. So this is an x-intercept. This will be a point on our graph. The coordinates are 2 and 0. And then they say the x-axis is a tangent to the graph at x is equal to -1. So it means that here, if x is -1, as we had already interpreted this information, this is both a turning point as well as an x-intercept, okay? And then we see that f prime of 1 is equal to 0. So we've got a turning point. Yeah, we've got another turning point at x is equal to 1. So that would be roughly here. This would be roughly x equals to 1. So we've got another turning point here. And now another crucial thing to note is that, so let's say this is our 1 over 2. I'm just labeling these as they relate to the information we are given. So f prime of x is 1 over 2 here, meaning that this is increasing, at when the value of x is equal to half, f is increasing, our function is increasing. So this is going to be crucial for us as well. Now let us try to put this all together. So I think it's actually going to be the same shape as that graph we were looking at previously, because firstly, we know that here we've got an x-intercept, right? So our graph is going to pass through x is equal to 2. We've got a turning point here at 1, and our graph is increasing, when x is 1 over 2. So if it is increasing, it means that um, it's going to be something like this. It needs to be increasing. So this is a turning point. Okay, let me try to do it. So I think it's going to be something like this, right? And it is increasing. Okay, it is increasing. Oh, so actually this shape, it's not really necessarily going to be the same as that one. We, okay, we do not have a y-intercept, but I think from here, it makes sense. It only makes sense if it's going to be something like this. Okay, yeah. Ooh, that's too sharp, man. It's not curvaceous as I would like it to be. Okay, guys. I mean, it's not gonna be perfect, but something like this. So let me just move this point to here, and I will just go through the information one more time to see if this makes sense. But I think it does. It's not exactly the same as that one we were, that graph we're looking at, but it has got similar properties to it in that there is this turning point, which is also an x-intercept. So firstly, you see, we're told that we've got two turning points. Here is the first one. This is the first turning point, and this is the second turning point. Great. Okay. Number two, here we are told that we've got an x-intercept at x is equal to 2 because as we can see here, the coordinates here are x equals to 2 and y equal to 0. So x-intercept at x is equal to 2, that checks out. And then the x-axis is a tangent to the graph of f at x is equal to -1. That's what we have here, you see. Let me even use a different color. You see that the x-axis form a tangent line to f at x is equal to 1. And as I said, this basically means that this is not on x is equal to -1 is not only a turning point, but it's also an x-intercept. So that checks out. And then f prime of 1 is equal to 0. So when x is equal to 1, the gradient is 0, right? Meaning that this is our second turning point on this cubic polynomial. And then lastly, we are told that f prime at x equal to 1 over 2 is greater than 0, meaning that our graph, when we've got an x value of 1 over 2 somewhere here, our function is increasing. So it agrees with what we have here. As you can see, indeed, our graph is increasing, including here at this specific value of x they decided to tell us about. So that is looking good. And so yeah, that's pretty much how the shape of this graph should be. And they say we must only indicate the x coordinates of the x-intercepts and the turning points. So we have absolutely done that, and we would get all of this 4 marks. So that is how amazing this question is. Very interesting. You know, you are just given information about this cubic polynomial. You need to be able to interpret this information to deduce how the graph of the function should look like. Okay. And then now here is the actual optimization problem. It's 10.2. So O is the center of a semicircle passing through A, B, C, and D. Okay, so that those are points at which our semicircle passes at. The radius of the semicircle is x minus x squared. I think we should note this. We're told that O is the center, so the radius is x minus x squared. X minus x squared is the radius, right? Meaning that even OB and AO are also equal to x minus x squared, including DO here, okay? And yeah, for x is greater than 0 but less than 1. So yeah, that's important to note. All right. And then triangle AOB is right angled uh at O. Okay, so we've got this angle of 90 degrees at O. So this is a right angled triangle. Cool. Now 10.2.1 says show that the area of the shaded part is given by this. Whew, hectic, right? But maybe not, not maybe not so much. It's important not to get intimidated with these problems. Let's just think about it carefully. So we want the area of that shaded part. Well, firstly here we've got a semicircle. We know that the area of a semicircle is pi r squared, right? Yeah, we know that the area of a circle, just a circle, is pi r squared. That's the first thing to keep in mind. Now, another crucial thing to note is that this part here, or this segment of this, of the semicircle, the segment AOB, let me even note it, AOB. So this segment, you should note that since this makes an angle of 90 degrees, right? Of 90 degrees. So a full circle, it has a full revolution of 360 degrees. So if this one is that, we can be able to work out whether what is, you know, how how am I gonna explain this? This fraction here is simply giving us whether how much of a single of a full circle, is this segment. So this segment, you see that it forms an angle of 90 degrees, but a full circle is 360 degrees. So as you can see, it means that this segment is just a quarter of a circle, because 90 over 360 is 1 over 4, right? So this is just a quarter of a circle. So that is very key here, because, so what this means, let me just write here. This means that the segment, AOB is 1/4 of a circle. It's 1/4 of a full circle. Therefore, the area of that segment as a whole. So the area of segment AOB, it's just going to be 1 over 4, a quarter of, of an area of a full circle. And the area of a full circle is pi r squared. So that's the first important thing to note here. And then we need to recognize that now we can obviously see that there is this line AB which is dividing this segment. And if we can now work out the area of triangle ABO, yeah, we can call it ABO. We know that the area of a triangle, it's half base multiplied by height, right? So let me just write that here. Half base multiplied by height. Okay, the base of this triangle, fortunately, we know that the radius is x minus x squared. So meaning that this is also x minus x squared. So the base of this is the radius and the height is also the radius. So we'll be able to calculate this, you see. And now, therefore, it means that the area of the shaded part, so let's say the area of the shaded part, okay, guess I'll just continue to write all of this in red. So the area of the shaded part is simply going to be the area of the segment. Area of segment AOB, right? That whole segment. Minus what? Minus the area of the triangle. Minus the area of the triangle ABO. So that's it, guys. That's all that we need to do here. So Yeah, I guess we can, if we like. Okay, it's fine. I'll just rewrite the formulas here. This is 1 over 4 pi r squared minus half base multiplied by height. Now we can go ahead and substitute in. We know that the radius for that circle is what? Is x minus x squared. So all of that squared, okay? We have to square all of this because x minus x squared is the actual radius, right? And then the base, like I said, as you can see, if you look into this right angled triangle, we can say that the base is x minus x squared and the height is x minus x squared. So overall here we'll just have x minus x squared all squared because we'll be multiplying the same thing. So this is the resulting equation. Now we just need to find a way to simplify it. So firstly, okay, I think what we can do, we can say that x minus x squared all squared is a common factor here. So if we take that out as a common factor, we're going to be left with 1 over 4 pi minus 1 over 2. Okay, and then yeah, and then on this side we can expand this bracket. This is a perfect square, so we can use the shortcut method. Sorry about that. So yeah, as I was saying, we can just use the shortcut of doing this. So this will be x squared and then x multiplied by negative x squared and then multiplied by 2 will give us the middle term. So the middle term will therefore be minus 2x cubed. And then for the last term, we just square the last term here in our perfect square. So that will be x to the power of 4. Okay, so let's put this inside brackets. And then here we can, because as I am doing this, I am comparing it to the area that we are, to the expression that we are trying to prove. So we can see that they have combined, these two terms together. So how can we do that? Well, the quick way to do that without maybe using a calculator, you would just imagine that you are multiplying here by 2 and also multiply the numerator by 2 in order to get a common denominator. So if you do that, then you'll have the same denominator of 4. So once you get a common denominator, you can just sum up the numerators. So on this numerator, we'll have pi, and then on this one, we'll have 2. So is this not similar to what they have there? It is similar, just that all that they have done. So let's just say, therefore, the area, all that they have done is that they started with this factor. So obviously, this is multiplication, so we can just switch them around if we want to. So just like that. Now let's rearrange these terms. Let's start with x to the power of 4, followed by minus 2x cubed, and then positive x squared. So there you have it, guys. We have successfully shown that this indeed is the formula for the area of the shaded part. That's a whole 5 marks, so it's very important. However, even if you were unable to do that, maybe you get stuck, you would still be able to answer 10.2.2. Which says determine the value of x for which the shaded area will be a maximum. Now, this is the main optimization part of this question. And for that, as you know, you just need to work out the first derivative. It's simple. So we want area prime, which will be the first derivative. So this x minus 2 over 4 is just a constant. So we'll just take it down as it is. X minus 2, I mean pi minus 2, not x minus 2. The pi minus 2 over 4 is just a constant. So we just need to we'll find the derivative, of the second bracket here. So that will be 4x cubed minus 6x squared plus 2x, right? And then, as you know, we just need to set this to 0 and yeah, solve this equation. So immediately, if we like, we can just drop this because this is just a constant term. Or, you know, let me just write it down. I'll show you what I mean. Let me do this. And then, yeah, well, I just need to drop this down as well. Okay, yeah. So this is what I mean. Obviously, we can now just divide by this pi minus 2 over 4 on both sides of the equation and get rid of it. So our main focus is then going to be this cubic, function here. And here on that cubic function, we can actually factorize by taking out x as a common factor. So fortunately here, you will not have to go through those, complex steps of solving of factorizing a cubic polynomial. But we can just take x out as a common factor and then look at this. Oh, actually, we can even do better than that because you see we've got 4, 6, and 2. So it's not that just x that is a common factor, but it's 2x. So let's take out 2x as a common factor. Now this will be 2x squared minus 3x plus 1. So look at how simplified our equation is now. This is how amazing mathematics can be. And then again, we can just neglect this 2x, or maybe let us not neglect it. It means that 2x equals to 0, right? Or maybe I'm rushing it, Let's start here. Or I think most people here would actually prefer to use the quadratic formula, so it's fine. Based on this, we can just say 2x equals to 0, or 2x squared minus 3x plus 1 equal to 0. So for this, I'll just use the quadratic formula. I guess this time around, let me do the right thing and start by writing it down. B squared minus 4ac all divided by 2a, and then we show the substitution. So b is negative 3. So here we'll have negative 3 plus 4. A is 2 and C is 1. Okay, now it's fine. It's all looking good. Then all divided by 2 into 2. All right, now quickly we need to use our calculators once again. Okay, A is 2, so I'll just change the values on this here without starting over. So C is 1, and then this will be 2, and B is negative 3, and yeah, we'll also have negative 3 here. So let's see. Okay, I like starting with a positive here. So we've got x equals to 1. So x equals to 1, or x equals to, let's see. I think it's gonna be 2, isn't it? Oh, it's 1 over 2. 1 over 2. Okay, so these are our x values, but now we need to make a selection. Obviously, from the 2x equal to 0, it means that x equal to 0. So remember, on the statement, we were told that this is such that x is greater than 0 but less than 1. Greater than 0 but less than 1. So x is equal to 0 is not it, obviously. X is equal to 1 is not it. The only x value here that is in between 0 and 1 is x is equal to half. Therefore, our final answer is x equals to half. Okay, I hope that is all clear, guys. That's pretty much all that we needed to do to answer this question. So now we are going to be moving on to another one. So now I want to start from the beginning here of our questions. I want us to go back to the beginning. So we've got this one from 2018. I specifically started with those two because, as you saw, they are set up in slightly a different way from other papers. The examiner, was, playing some tricks, with the metrics in those years, as you saw for yourself. Now, yeah, we've got this one, and from 2018. And again, guys, as you can see here, there's nothing too hectic here, nothing too hectic. You just need to be careful. Like for an example here with 8.2, you are looking for dy dx. So for the derivative of y with respect to x. But look on how 8.2.2 equation is provided to you. It means that before you do anything here, you need to make y the subject of the formula. So it's not that hectic at all, because immediately you see that actually here you can take y out as a common factor, and then you'll be left with x minus 1, and then equals to 2x squared minus 2x. And then after that, what is it that you can do? Well, you can divide both sides of the equation. Okay, before we even get there, we can do better. Okay, this looks interesting. We can also factorize on the right hand side. 2x is a common factor, so taking out 2x will leave us with x minus 1. Sorry about that. And then here, as you can see now, this, x minus 1 will cancel with this x minus 1, leaving you with just y equals to 2x, and you can easily differentiate this. Obviously, dy dx will be equal to 2. So you do need to be creative sometimes when it comes to these problems. Otherwise, these are free marks for you guys. And I want the optimization problems to be free marks for you as well. So let us look into this one, which is, quite shocking immediately when you look at it, because why the hell do we have proportionality in paper 1? So this question is like paper 2 in paper 1 basically. But anyway, we gotta do it. I mean, this happens even sometimes with paper 2 as well. You often see questions that, look like paper 1 type of questions. So it happens. So you must be ready for such things as well. In triangle ABC, so let me use a pointer here so that you can follow. So we've got the big triangle ABC. So they say D is a point on AB. Here is D. Indeed, this is a point along the line AB. E is a point on AC. Here is E. Indeed, it's a point along AC. And F is a point on BC. And similarly, there is point F. Okay, and then they say such that DECF is a parallelogram. So we've got a parallelogram here, DECF, DECF actually. So here it is DECF. That's the parallelogram. Hence we've got, those parallel, opposite sides parallel to each other as expected in a parallelogram. And then we are given a ratio. BF, the ratio of BF to FC is equal to 2:3. So I think this is where kind of the proportionality will come into play, because immediately when I saw these parallel lines, I thought of proportionality. So we are told here that the ratio of BF to FC is 2. So let's just indicate this as, like this. So this is 2, and then this is 3. Okay. And then they say the perpendicular height AG is drawn intersecting DE at H. Intersecting DE at H, here is this perpendicular line AG, as we can see. And then additionally, we are told that AG is equal to T units. So I would immediately indicate this here. So this is T. Okay. And then BC is equal to 5 minus T. B to C. So where is that? Oh, okay. This whole side here, B to C, is 5 minus T units. So I'll just write that here. So this is 5 minus T units. Okay. And then 10.1 says write down the ratio AH is to HG. Very interesting. So again, as I had already said, it's clear that we'll have to use proportionality for this. So how are we gonna do it? I think we need to start from the side, for which we know we know the ratio. So we know the ratio on this side BC. So whatever it is that we are gonna do, it must start from here. Okay, so I think what we should do is we must start by focusing on the bigger triangle here, and I'm talking about the triangle ABC. And then you'll notice that here in triangle ABC, we've got the line, okay, let me try to draw it again. We've got the line DF, and this line DF is parallel to the other side of this triangle AC. So we've got those parallel lines. So if that's the case, if we see that the ratio of BF to to FC is 2:3, this ratio should be the same as the ratio of BD to DA. You see? So here, this should be 2 and this should be 3. So the ratio of BD to DA is 2:3. That's the first thing to note. And now after noting that out, we are going to focus now on another triangle here, because we see that we do have got also this triangle now. Now it's the triangle that actually has AH and HG. So it's triangle ABC. No, ABG. If you just focus on triangle ABG, you see that here on triangle AGB, we've got this line DH. You see this line DH, which continues to move to F. That line is parallel to BC. Therefore, we can also say that DH is parallel to BG. You see? And if that's the case, it's clear that since we now know the ratio of AD to DB, that ratio should be equal to AH is to HG. So you see, just like that, we have finally worked out, the ratio of AH to HG. So there is no, specific working that you are expected to show for this question, but you just need to be able to work it out and then write it down. As you can see, unfortunately, all that work is worth only a single mark. So the ratio of AH to HG is 3 is to 2, guys. Okay, and then moving on to 10.2. Now in 10.2, we need to calculate T if the area of the parallelogram is a maximum. So that's the, the optimization part of this problem. So from the question, you can immediately see what it is that you are going to optimize. You are optimizing the area of the parallelogram, based on the question. Hence here, they even given us the formula of the parallelogram. So it's just base multiplied by height. And that's very, kind of them to do that. So let us work out what this area is going to be. We know that it will be base multiplied by the perpendicular height, right? Okay, now let me just clean this up. Let me try to clean this up. Okay, that's better. So now you will have to recall now, your, grade 10, I think even grade 9 work, with the ratios. Remember how, to work with the ratios? Well, that's exactly what we need to be doing here. So the base of the parallelogram. So let's just note our parallelogram. It's DE, okay, DF, FC, and the other side is EC. Okay, so there is our parallelogram. As you can see, the base of this parallelogram is FC. So we need to find a way to work out whether what is the length of that side FC going to be equal to. Well, we are going to use this because remember, B to C, you see, B to C, BC is equal to 5 minus T. But we know what's the ratio between BF to FC. That's what we are going to use. So it means that the base here is going to be 5 minus T. But now, if you remember how to use ratios, it means that we must multiply this 5 minus T by 3 because we want to know whether what fraction of this 5 minus T is equivalent to FC, right? So FC on the ratio is 3, but then you will divide by what? You'll divide by 2 plus 3. Our ratio is 2 is to 3, and FC on that ratio is 3, and then you divide by 2 plus 3, which is 5. I hope this makes sense. And then we must multiply by the perpendicular height. The perpendicular height is HG, as you can see, is HG. So what is HG going to be equal to here? Again, we know that the full length of AG is T. So we'll multiply by T, and then using our ratio, we'll work out what is HG in terms of T. So as you can see on the ratio, the part HG corresponds to 2, and then we'll divide this by 3 plus 2. So we'll divide it by 5. So that's exactly what we need to do here, and then we'll be able to get an equation for the area of this parallelogram in terms of T. So I think now what we can do, maybe let's start by expanding these two brackets. So what is 5 multiplied by 3 over 5? Well, that will be 3 because the 5s will just cancel each other, right? So that will be 3. And then what is negative t multiplied by 3 over 5? So that will be minus 3t over 5. And let's put this inside brackets. It's important because all of this still needs to be multiplied by what? By t, or by 2t over 5, because t into 2 over 5 will be 2t over 5. Okay, so this is what we need to do. Let me just fix this bracket. And now let's multiply again. So 3 multiplied by 2 over 5, that will be 6 over 5, and then multiplied by t. And then minus 3 over 5 multiplied by 2 over 5, this will be minus 6 over 25. And then t multiplied by t is t squared. So this is your area in terms of t. Okay, I'm used to x. Now I'm writing in terms of x, but yeah. So this equation here is basically a as a function of t. And as you can see now, this equation is actually, a quadratic equation, because you see you've got t squared and then you've got t, then clearly the constant term is just 0 here. And what is important to note is that the coefficient of the t squared is negative, meaning that if you were to draw a graph of this quadratic, it would be concave downwards. It would be something like this. Hence, it makes sense why here we can be able to, to find the maximum of this area, because the maximum will be at the turning point. So finding the maximum, in these optimization problems, specifically in a problem like this one, you are essentially just working out, the turning point, of this quadratic equation. And to do that, you can just work out the first derivative, which will be 5 over 6. And then this will be 2 multiplied by 6, which is 12. And then over 25 multiplied by t. And then we set this to 0. And then we need to solve for t in the resulting equation. Here and here is that equation. So I would just take this to the left hand side to get 12 over 25t equals to 5 over 6. And then you need to solve for t here. So you just need to make t the subject of the formula. So in your calculator, you can quickly do that as follows. This will be 5 over 6, and then you multiply by 25 over 12 on both sides of the equation. So this is what we are getting. It's 1,73. Okay, 1,73. So 1,73 units, because remember that t was one of the sides here. So that's the value of t such that this area will be a maximum. So it's not too bad at all, guys. Okay, so I hope that this makes sense. And by the way, what I was telling you here, it also actually goes to show you that if you want, you can also be able to find this exact same answer by using the formula t equals to negative b over 2a, because on this equation, here is your quadratic equation, right? You see that the value of b is 6 over 5. So you'll have minus 6 over 5. And then let's just write the division as follows. Divide by 2a. And a is negative 6 over 25. And then, as you know, this essentially means that we can change that division to a multiplication and then invert, this side. So if we do that, here we'll have minus, well, firstly, the negative signs will just, cancel each other anyway. So let me just remove this negative sign. Okay. And then here we'll have 2 into 6, which is 12. So, and then this will be 12 over 25. You invert that to 25 over 12. Oops, my calculator is hiding. Sorry about that. It's hiding what I'm trying to show you. So here's what I'm talking about. You can use this formula t equals to negative b over 2a. B, what is the value of b? It's 6 over 5. So this will be minus 6 over 5, right? We also take that negative into account. And then I'll just change to this division sign. So divided by 2a, and the value of a is negative 6 over 25. And then 2 multiplied by 6 is 12. So this will be 12 over 25. But then, firstly, the negative signs cancel each other. We can change this division to a multiplication and then invert this fraction to 25 over 12. And then this is what you get. And as you can see, it's exactly what we had. Let me show you the calculator again, because this is exactly what, we oops, oops, oops. Why is it not exactly 6 over 5? Oh my goodness. So I made a silly mistake here. Glad that I actually thought of showing you this, because I was not gonna say it, but I'm sure that many of you caught this mistake. So this is supposed to be 6 over 5, not 5 over 6. Guys, I hate making these mistakes. And I do that a lot, especially when I am talking and explaining. So bear with me, guys, bear with me, and try to ensure that you follow what I am talking about. You know, so yeah, this should have been 6 over 5. So this answer here will change slightly. This should be, okay, I'm now changing it here on the calculator. So it will be 6 over 5 multiplied by 25 over, oh, let me show you the calculator. Yeah. So this is how this is supposed to be. Okay. So this should have been 6 over 5. 6 over 5. So this is not going to be our value of t. But yeah, I ended up saying this because I was just trying to show you that actually in this case, to show you that indeed this is the interpretation when it comes to optimizing is the same, as we do when we are working out the turning point of a function, of a quadratic function, especially. You see that here you end up getting the same answers using either one of these methods. So whether you're using this method or using this one, you'll get the same answer. So you multiply this 6 over 5 by 25 over 12, the reciprocal, so that, to cancel out, the 12 over 25 on the left-hand side. So yeah, the answer here, the correct answer is 5 over 2, which is 2.5. 2.5, and you can get it using, either way. But I'm just showing you this, otherwise I would you know I would say that, well, just stick to using calculus. Just find the first derivative, set it to 0. Yeah, but this is important to note where this comes from. Why do we say that we are optimizing, we're finding a maximum here? It's because the graph here that we would get from this equation of a, it would be parabolic and it would be concave down. So the turning point is a maximum. Okay, now let us move on to another question. So we've got question number 9 here, looking quite interesting as well. So okay, guys, let's do this question. Okay, let me just maybe let me put this here. Yeah, I think, let me arrange like this. This is a better arrangement. All right. Now we have here a right circular cone with radius P and height T. And this is machined or cut out from a solid sphere with center C with a radius of 30 centimeters as shown in the sketch. So in this case, they have shown us all of that information on the sketch. We are also given some formulas here for the volumes of the sphere and the cone. So quickly, let's jump into the first question. From the given information, express the following. Firstly, we need to express AC in terms of T. So AC, if we go back into this diagram, as you can see, this is AC. So they want us to express AC in terms of T. As you can see, T is, the perpendicular height from A to the top of that cone. So this is actually very straightforward, guys, as you can see, because it means that AC, so for 9.1.1, it means that AC is just simply equal to T, that whole perpendicular height, minus the radius, because we are given that the radius from C up to the top of that cone is 30. So AC is just simply T minus 30. And then 9.1.2. Now we need to express P squared in its simplest form in terms of T as well. Well, P squared, clearly we can get this P squared from this right angled triangle that is formed here. So we just simply need to use Pythagoras, right? I'm sure you managed to figure that out, right? Because we've got a right angle triangle and we've just worked out AC. We know the hypotenuse side is 30 and there is P. So let's just use Pythagoras theorem. So the hypotenuse side here is 30 squared. So let's square it. The square of the hypotenuse side will be equal to the sum of the squares of the other two sides. So our P squared as well as AC. So AC squared will be T minus 30 all squared. T minus 30 all squared. So we just now need to make P squared the subject of the formula here. So we'd have to take, this perfect square or this bracket into the left-hand side here. And if we do that, well, firstly, 30 squared, what is that equal to? I think that's 900. I'm just gonna, yeah, but I'm sure it's 900. I'm just confirming. Yeah, it is 900. So that's 900. And so we'll have minus T minus 30 squared, right? Equals to P squared. So we need to simplify it. Therefore, we need to expand, that bracket. So we'll have 900. And then if we expand here, the perfect square will have T squared minus, so T multiplied by 30 multiplied by 2, that's minus 60T. And then plus 900. So yeah, equals to P squared. So actually here, immediately you can see that the 900 will cancel with this 900, because when we are multiplying the negative into this bracket, we'll get minus 900. So overall, what we are going to be left with is minus T squared plus 60T is equal to P squared. So yeah, let's just say that it means that P squared equals to, we can write it as follows, 60T minus T squared. Yeah, so we can just switch them around so that we start with the positive term and then the negative term. Okay, so that's 9.1.2, guys. Now moving on to 9.2, that this is the volume, the formula for the volume of a cone. So here for 9.2, we'll obviously make use of that But all that we need to do, so we'll have 1 over 3 pi. And then what is our r squared going to be? Well, note here that the radius that we are talking about now is the radius of the cone. And the radius of the cone is AB, and it is equal to P. So it means that in place of r, we can sub in P, and then we'll get P squared. Okay, our height h it's equal to T. It's equal, you can see we have just worked out an expression. You can see we have just worked out an expression for P squared, T squared. Okay, so that's it, guys. And just, yeah, I think we do need to simplify it because we want it to look like that. So let's simplify this. 1 over 3 multiplied by 60 will be 20. So this will be 20 pi. 20 pi. Okay, did I miss something? Where is that square coming from? Oh, yes, indeed, I'm missing something. I'm now forgetting this t. So there is that t that is multiplying. So 3 pi t squared. And then we still have the t that is multiplying outside here. So obviously, after doing this, you will just get 20 pi t squared, because t multiplied by t will be t squared, minus 1 over 3 pi t cubed, because t squared multiplied by t is t cubed. Okay, so that's how we can show the volume of this cone. So this is the volume of the cone in terms of x. And then after that, is you can calculate the value of t for which the volume of the cone will be a maximum. However, this time around, we've got a cubic function here. You see, this volume is cubic, and this makes sense because this is a volume that we are talking about. And if you are thinking about a volume, the units, or let me say, in order for you to find a volume, you usually need to multiply 3 sides. For an example, if it's a rectangle, let's say its length times base times the perpendicular height. So yeah, that's why it's cubic, because if, for an example, each of these are, for an example, in terms of x, then this would be x cubed. So I mean, it makes sense why v is a cubic. And even with a cubic, as you know, we do have got those maximum points, those local maximum points in a cubic polynomial. Yeah, so it makes sense why we would be optimizing here as well. But I mean, it's nothing hectic. You don't need to think about it even too hard. You just need to find the first derivative. So v prime x, so that will be 40 pi. That will be 40 pi t, right? And then minus, so 3 will have negative 1 over 3 multiplied by 3, which will just be negative 1. So we'll end up getting negative pi t squared. And then we need to make this 0. And then here, if we like, now what we can do, we can take pi t as a common factor. Pi t as a common factor. If we do that, here we're going to be left with 40 minus t. Yeah, with 40 minus t. I hope I'm not making a mistake. Let me just double check. Yeah, so we've got 20 pi t squared minus 1 over 3 pi t cubed. Just want to make sure. So the derivative here, it's 2 multiplied by 20, which is 40 pi t, and then 3 multiplied by negative 1 over 3, which will just be negative pi t squared. Okay, that all looks good. And then taking out pi t as a common factor, we are left with 4d minus t. Yeah, I think this is fine. And then from this, it means that we can say pi t equals to 0, which means that t equals to 0, or 4d minus t equals to 0. And if you solve this, you'll get that t equals to 40. And obviously t cannot be equal to 0, right? So it's a height, so it must have some length. So it's gonna be 40 units. 40 units. So back to the question again. Yeah, we just wanted the value of t. So our value of t is t equals to 40. Therefore, t equals to 40 units. Okay. And then moving on to 9.4. Now they say, what percentage of the sphere was used to obtain this cone having maximum volume? Okay. Interesting. So what percentage of the sphere? Because remember that this cone, we were told that it is being cut out from a solid sphere. So question is, what percentage of this sphere was used in order to obtain this cone which has a maximum volume? So interesting question, guys. Let's do it. And in fact, let me, yeah, I want to see that volume of the sphere. So to answer 9.4, number one, let us work out whether what is the maximum volume of this sphere, of the cone. Let's start with the cone. The maximum volume of the cone, in order to get it, we'll just take our maximum, our value of t that would make the volume of the cone a maximum, and we had found that to be 40. So we'll substitute in that t equals to 40 into the original equation of of the volume of the cone. So here it is, that equation we're showing. So this is 20 pi into 20 squared minus 1 over 3. Okay, pi into 20 cubed. Okay, and of course we are gonna need a calculator for that. So let's use our calculators. So what is 20 multiplied by pi multiplied by 20 squared? Minus 1 over 3 into pi multiplied by 20 cubed. Okay, as you can see, we are getting this. We are getting 100. Oh, it's 16,000 pi over 3. 16,000 pi over 3. 16,000 pi over 3. And I would advise you just leave our answer like this here. And now the next thing that you need to do, so this is just the maximum volume. I think, let me clarify it here, and I would also advise you to do the same thing, in a similar question. Let's note here that this is the maximum volume of the cone. Now, the next thing is to work out the volume, just the volume of the sphere. What was the volume of this sphere to begin with? And then we'll be able to work out what percentage of it was used. So luckily, we are given here that that's the formula, for the volume of a sphere. So it's 4 over 3 pi multiplied by r squared. So remember that the radius for the sphere was also given, that the radius of the sphere is 30. It has a radius of 30 centimeters. Oh, okay, so actually our units here are in centimeters. So, but yeah, anyway, here we've got 30. So this will be 30 cubed, right? Yeah, 30 cubed. So it means that our units here, I just realized that, okay, we're given that the units are centimeters. So we'll have cubic centimeters here. Now back to this using a calculator. Okay, so what is 4 over 3 multiplied by pi multiplied by 30 cubed? Oops, not 330. So now as you can see, okay. I think that we may have made a small mistake somewhere. But yeah, anyway, right now we see that this one, so 4 pi multiplied by 30 squared is 36,000 pi, okay? 36,000 pi. There is something that I think we'll have to check. So here we are getting 36,000 pi. So that is our volume of this sphere. So just to double check here, 4 over 3 pi 30, because for the sphere, the radius is 30. So yeah, I don't think there's anything wrong with this answer, but it's not quite what I was expecting. So isn't there? How? How? So what's my excuse for this mistake I have done here? I substituted in 20 instead of 40. Aish, what a silly mistake. This should be 40. I'm sure that again you guys noted that. So this is 40 squared, and yeah, this should be 40 cubed. And then there's a minus here. Yeah, because the value of t at the maximum is 40, not 20. I don't know why I made that mistake. But yeah, let's quickly fix that and work out the correct value here. So that's 20 into 40 squared minus 1 over 3 pi into 40 cubed. Yeah. Oh, I forgot the pi here. So 20 pi 40 squared, 1/3 pi 40 cubed. Yeah, now I like this. 32,000 over 3. So yeah, this should be 32,000 over 3. So now immediately here you can actually see that, yeah, the volume of the cone is just 1/3 of the volume of the sphere. So to calculate that percentage of the sphere used, it's clear that that percentage is 33%. But yeah, if you want to calculate it, you can then take the volume of the cone that we have found, divide it by the volume of the sphere, and multiply it by 100. But clearly you can see the volume of the sphere is 36,000, but the volume of the cone is 32,000 over 2. So yeah, obviously with the pi, with the pi's there as well. So basically that will be 33.33%. So we've got 33.33%. So that's the answer to 9.4. All right. And now, yeah, we've got another one, guys. Here's another one. And this one is from May, June 2023. Okay. May, June 2023. Again, we are not going to just discuss anything there with question number 7. Let's just get into question number 9. So, yep, we've got yet another cone. So yeah, it's very, very similar to the question we've just gone through, right? Very, very similar. So, I mean, I think you should be able to do this because if I look, into the information we're given here, it's also similar, to the previous one. So the radius of the cone is r centimeters. The height is AB. The height is AB, right? And inscribed in this sphere with center O and a radius of 8 centimeters. So the sphere has a radius of 8 centimeters. So this is also 8 centimeters. So again, you see you've got a right angled triangle here. I think it's very, very similar to the one we've just gone through. So we can just, I'm going to skip this, but I would advise you to pause the video and try to work this out. As indicated here, it's from 2023. So you can just go through it. And I hope that's not a mistake. I hope I'm not making a mistake because I usually go with the order of the years. But I mean, it's absolutely, if it's not 2023, you can just check other years, between 2018 up to 2023. Yeah, the May, June, as well as the final or end of year exam, the November exams. So, yeah, this is a good question to practice what you've just learned, in the previous question we did. Now, here's another interesting one, and this one is from DBE November 2019, as you can see. So again, free marks for you guys. Unfortunately, there is not enough time for me to go through this, but this is relatively straightforward. The focus today disconnecting. Okay. Okay, sorry about that. I had a technical glitch. I think we're alive again. Okay. So we've got question 8 here. After flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. The path that the insect crawled can be described by this equation. Cool, so we are given the equation where h is the height above the floor and t is the time in minutes since the insect started crawling. Okay, so maybe, yeah, this is quite interesting. I'm gonna try to, draw some diagram to depict what is happening here. So imagine that this is your insect with this dot here. So we've got an insect and this was flying. So it was flying a short distance. Let's say it was flying in this direction. So there is our insect flying and then it came to rest on a wall. So let's say this is our wall. So our insect moved up until it came to rest. It stopped right there on the wall. And thereafter, it started crawling on the wall. But then here, we do not know whether it started crawling upwards or, downwards, but it started crawling. Yeah, and then the what? The path the insect crawled can be described by this equation, and h here is the height in centimeters above the floor. Okay, that's important actually. Let me underline it. So h is the height in centimeters above the floor, and t is the time in minutes since the insect started crawling. So let's see, let's look into the questions. 8.1 says, at what height above the floor did the insect start to crawl? Okay, so we are told, we're already given an equation here, so this shouldn't be hard. We just want to know whether, if this is the ground here on my diagram, let me say this is the ground, this is the ground, and the insect started crawling here. So what was the height above the ground when it started crawling, right? So we know that here is our equation. So if we want to know what was its height above the ground, well, when it started to crawl, remember that the t on this equation is the time since the insect started crawling. So when this insect reached the wall, the time was 0. It's clear that t was equal to 0 if t is the time since the insect started crawling. Therefore, if we want to know at what height above the floor it started to crawl, it started at t equal to 0. So 8.1 is straightforward. We just make t equal to 0 and then we solve the equation. So this will be 0 minus t, and then, yeah, if t is equal to 0, then as you can see, all of these terms, the minus t2 squared plus 3t, are going to be 0 because t is 0. So negative 2 multiplied by 0 is 0. 3 multiplied by 0 is 0. So I'll just leave that out and just only show the minus 6 on that second bracket. So we'll have minus 6 into minus 6, which is, I think that's 36, right? So yeah, the insect started to crawl at a height of 36 meters, I mean centimeters, above the ground. Okay, now we know that. Moving on to 8.2. How many times did the insect reach the floor? So if you think about this question, when the insect reaches the floor, at the floor, the height is 0. At the floor, h is 0, right? So basically, we kind of just need to work out the x-intercepts of that equation, because at the floor, h of t is equal to 0. So this is what we need to solve. But note that we want to determine whether how many times did it reach the floor. So in other words, we want to know how many x-intercepts does this equation have. So our equation is t minus 6, and then this is minus t, minus 2t squared plus 3t minus 6 equals to 0. So the first one, luckily this is already factorized for us, you see. So we do have t equals to 6, and then from this one we'll have minus t2 squared plus 3t minus 6 equals to 0. Okay, and then let us just use the quadratic formula. So yep, so minus b is 3 plus the square root of b squared. So in other words, 3 squared minus 4a, which is negative 2, c, which is negative 6, all divided by 2 into a, which is negative 2. And we are getting a math error. Let's just double check if we have substituted in correctly. So yeah, um, b is indeed positive 3. Okay, for AC, so a is negative 2, and a, yeah, is negative 2, and c is negative 6, a is negative 2. So yeah, it looks like we are getting an error. Maybe you might say that I should have made the value of, I should have changed the sign of a here to be positive, maybe by multiplying by -1. If we do that, because yeah, of course, that's good practice. when dealing with a quadratic equation. That's how what we usually do. So if you do that, then this will change the signs here. This will be positive now, and this is also going to be positive, but b is now going to be negative. So a is going to be positive, but still, as you can see, we're still getting a math error. So this simply means that this equation cannot be equal to 0, guys. That's all it means. And therefore, we only have one x-intercept at t is equal to 6, meaning that this insect is only going to reach the floor once when the time is equal to 6 minutes. So the answer to this question is that therefore the insect reached the floor it reached the floor once, right? Or let's say one time, or one time. Why is that? Because we are only getting one x-intercept, or we're only getting one time, and that time is t equal to 6, you know, at which the height is 0 here, meaning that the insect has reached the floor. Very interesting, right? And then we have 8.3. And 8.3 is asking us to determine the maximum height that the insect reached above the floor. Oh, well, now for this one, we need to work out the first derivative and equate it to 0, all that stuff. It's sort of the optimization part of this question. So yeah, before we can be able to work out that first derivative, we need to expand this, the brackets here. So okay, I'll try to just zoom in a little bit so that you can see the equation properly, and then let me just put this here. So we will have t multiplied by negative 2t. That will be negative 2t cubed, and then this will be plus 3t squared, and this will be minus 6t. Okay, and then we multiply by negative 6. Negative 6 into negative 2, that's positive 12t squared, right? Yeah. And then negative 6 into 3, that's going to be negative 18t. And then negative 6 into negative 6, that's plus 36. All right, so this is our equation. Now we need to add up the like terms. So what are the like terms? Here we have this negative 2t cubed. So this is going to be plus 15t squared. Minus 6 minus 18 is going to be minus 24t. 24t, right? And then plus 36. So this is what you should get, provided that I have not made a mistake here. If I have, you can just correct it, following the procedure that I am explaining. So now that we have a first derivative, now that, we have a full equation, we can work out the first derivative of h. So this will be minus 6t squared plus 30t, right? Plus 30t, and then minus 24. And then we need to equate this to 0. Yeah, this is what we're now getting. And I think we can simplify this equation by dividing by negative 6 throughout. So this will be t squared This will be negative 5. So we are dividing by negative 6. So this should be negative 5t. And then this should be negative, well, positive 4. Positive 4. Yeah, yeah. So this is nice because it's something that we can easily factorize. I don't know about you, but if an equation is easily factorizable, that's what I'm going to go with, other than using the quadratic formula, because it takes time. You need to write that formula down, substitute in, and then punch in the values in your calculator. But it's a matter of preference. So our factors of 4 are 4 and 1, and they can give us 5 indeed. So since 4 is positive here, the signs will be the same and they will both be negative because the middle term is negative. Therefore, t equals to 4 or t equals to 1. So we want the maximum height that the insect reached above the floor. And right now we are getting two values of t. That's what is happening here. We are getting two values of t. So we need to choose whether which one is going to work for us. And there are two ways, to do it here, for determining this maximum height, because here are your two values of t. You can sub in both of them into the original equation of h, right? So I'm talking about this one right now. You can sub in into this equation and then see whether, or in fact, if you like, you can even sub in into the factorized one. Either way, you should get the correct answer. So you need to do that and see whether which height here is going to be the biggest, and that will be your maximum height. Or alternatively, you can just work out, for an example, the second derivative and determine whether, and see whether, because if you work out the second derivative here and then sub in each of these points and see whether which one gives you a negative value, because if the second derivative is negative, it means that your function is concave downwards. And if therefore at that point you've got a downwards concavity, it means that it will be your maximum. But I think the easiest way to do it is just to substitute in both h of 4 and substitute both t is equal to 4 and t is equal to 1 into the original equation and see which one gives you a bigger value. So I'm just going to leave it here for you to do it. The one with the biggest value will be your maximum height. Okay, so that's it, guys, for this question. Very, very interesting. We've got, more interesting question, guys. We cannot go through all of them, but I think this one is interesting. It's also interesting and a bit different from the ones that we have done. So I would really, really like for us to cover it. I would like for us to cover it. Let me see. How long has the stream been going now? 1 hour 39. Okay, that's not too bad. It's not too bad. But yeah, I think this is probably going to be the last question. So we've got a closed rectangular box. Okay, a closed rectangular box has to be constructed as follows. Okay, here are the dimensions of this rectangular box. The length of the base has to be 3 times its width. The volume has to be 5 cubic meters. And then they say the material for the top and the bottom parts costs 15 rands per square meter, and the material for the sides costs 6 rands per square meter. And we need to show that the cost to construct the box can be calculated by this equation. Okay, I was too fast as I was reading through this. Now let us interpret, the information as we are reading. So these are the dimensions. It's simple. This is the length, the width, and the height of this rectangular box. Maybe let's try to draw it. I'll try to draw it. Um, so it's going to be something like this. Okay. Okay, there we go. It's coming together. Does not have to be perfect. So yeah, let's just do this now. Obviously, as you can imagine, we also have those other sides. Okay, so the length is L. So let's say this is L, perhaps using a different color. This is L. The width is W, KW, and this is our height. So obviously it means that this will also be L, that will also be L, and so on and so forth. This will also be H, that will also be H, this will also be W, this will also be W, and this will also be W, right? So that's it for the first point. Now, they say the length of the base has to be 3 times the length of its width. So let's write this down. They are telling us here that the length of the base, okay, wait a minute. Oh yes, the length L of the base, the length L of the base has to be 3 times its width. 3 times its width. So mathematically, that's what they are telling us. L is 3W, right? 3 times the width. The volume V must be 5 cubic meters, but we know that the volume here, it would be the length multiplied by the width multiplied by that height. So this should be equal to 5 cubic meters. So now that we have noted down all the information, let's move on to the further statement. So they say the material for the top and bottom parts. So we're just talking about the top of our rectangular box and the bottom part. They cost 15 rands per square meter. 15 rands per square meter, guys. So it means that they cost 15 rands per square meter. Per square meter. Yeah, this is how you can write per square meter. So it means that yeah, obviously a square meter is an area. So this is based on area, this rate here. And you can also think about it this way. It means that we have 15 rands over meter squared. That's also another way to think about it. And the material for the sides is 6 rands per square meter. And yeah, that's also, this will also be interpreted in the same way, 6 rands per square meter. And then in 9.1, we have shown that the cost to construct the box can be calculated as this. Yeah. So now let's think about that. So this cost, okay, my laptop is tired now. So the cost here will be equal to the cost of the bottom and top parts, right? The cost of the bottom or top and bottom parts plus the cost of the sides. All right. So again, for the, for the top and bottom parts, well, we see that the rate is 15 per square meter. 15 per square meter. So we do not want 15 per square meter. We want the actual cost. So we need to multiply this 15 per square meter by the actual square meters, or in other words, by the actual area of these sides. So this 15 here must be multiplied by the area of the top and the bottom parts. So obviously the top and the bottom part will have the same area, so we can just say 2 times, and that area, it will be given by length multiplied by width. So length multiplied by width, right? And then for the sides, we'll do the exact same thing. The cost is 6 rands. We need to multiply that because this rate here for the cost is per, the square meters or the area. So we need to multiply by the area in order to only get rands, because after multiplying by the area here, the area is in square meters, then the square meters will be cancelled out and you'll only be left with rands. The same thing applies for the sides. So as you can see with the sides now, we need to be careful. We need to be careful because we've got 4 sides, and each of each pair of these sides will have the same area. So the first pair, it will be L multiplied by H. So if we're talking for an example about this side as well as the one opposite it, so it will be L multiplied by H. That will be the area for that side, and we must multiply this by 2 as well. We must double it. So let me just say 2 multiplied by L multiplied by H. And the same thing for the other 2 sides. The other 2 sides, we've got 2 of them, and their area, it will be the width multiplied by the height. Okay, so now at this point, this is what we have. Now remember the information were given. They were given that L equals to 3 times the width. So here we can say this is 2 multiplied, and then in place of L we can just write that 3W, right, in place of L, and then multiplied by the width. And the same thing can be done here. In place of L we can just write 3W. Okay, yeah, so this is, we are gonna leave this as it is, because as you can see on that equation, we do have WH. So now let's just expand here. What is 15 multiplied by 2? That is 30. 30 multiplied by 3 is 90. And then W multiplied by W is W squared. So that's where the W squared, the 90W squared comes from there. And then here you will notice that, okay, we have 2 multiplied by 3 on the first term inside the brackets, which is equal to 6. And then 6 multiplied by 6 is 36. And then 36 WH, because that's W times H, right? And then we've got 2 here, but this is 6 multiplied by 2, which is 12. So 6 multiplied by 2 is 12. Again, W multiplied by H is WH. So that's how we get this equation of 90 squared, and then 36WH plus 12WH is going to be 48WH, guys. So that is how that equation for the cost comes about, okay? And you get your 4 marks. Now 9.2, they say determine the width of the box such that the cost to build the box is a minimum. So again, that's the actual optimization problem here. But before we can be able to move on here, we need to find a way to get rid of this h here. So I'm gonna call this equation 1 and call this one equation number 2. What we are going to do, we will sub in equation 1 into equation number 2, and I'll just leave the v out. So this will be, so in place of L, we are going to have 3W. So I'm substituting 3W in place of L, multiply by W, and then multiply by that H, and this is equal to 5. You see? And now we just need to make H the subject of the formula here. So if we do that, we'll have H equals to 5 divided by what? Divided by 3W squared. So that's our H. So in 9.2, that's the very first thing that we need to do. So for this cost, I'll say this is cost as a function of W. So W is our variable. So 90 W squared plus 48 W, and H is 5 over 3 W squared. You see? That's all that we gotta do. Now let's simplify it. I guess this is a cost. Maybe instead of writing cost, let's just say it's C. Let's just abbreviate it with C as a function of W. So 90 W squared. And then here, as you can see, this W will cancel with that square. So we'll have 48. For this, I'll use a calculator. I'll just calculate the value of 48 multiplied by 5 over 3. And that's equal to 80. So this is plus 80. And then we'll be left with that W in the denominator. But since at the end here, we want to work out the first derivative. So let's bring that to the numerator. So it will be W to the power of -1. You see? Now let's work out the first derivative of our cost. So 2 multiplied by 90, that's 180 W. And then this will be minus 80 W to the power of -2. And then as usual, we set this to 0. 180 W minus 80 W to the power of -2. Okay, so now what would I advise we do with this? Okay, I think let's take our -80W into the left-hand side. So that will be positive 80 over W squared in the denominator. So we can return that W in the denominator. So equals 280 W. Now we can multiply by W on both sides of the equation. So we'll have 80 equals to 180 W cubed. Yeah. So now, okay, I'm just gonna flip the sides of, of my equation around. And as I do that, I'm also gonna divide by 180 on both sides of the equation, because what is 80 divided by 180? Let's see if that can simplify. Yeah, that can be simplified to 4 over 9. So it will be 4 over 9. So if we divide by 180 on both sides of the equation, we'll get W cubed equal to 4 over 9. Now we want W here. So what we can do, we can multiply by let me show you here. We can multiply the exponents on both sides of the equation by 1 over 3. And do the same thing here. Multiply that exponent by 1 over 3. And see what that is going to give us. 4 over 9 into 1 over 3. So basically we are cube rooting on both sides of the equation. So what is 4 over 9 to the power of 1 over 3? So, well, the answer that I am getting is 0.76. I don't know if it makes sense. It's supposed to be that answer, but 0.76 is what I am getting. I hope that I haven't made some silly mistakes. I really hope so. So let me actually just test it and also show you the calculator. I guess what we can do with this value, yeah, I'm just going to substitute it in here because we're solving this equation. What is 180 multiplied by this answer? minus 80 into W, and which is our answer, to the power of negative 2. Yeah, that is equal to 0. So we have solved for W correctly here. I guess what I might have to ask myself is whether or not I did not do a mistake before that. But I mean, I guess maybe this value here does make sense, because what can we do? So determine the width. So it means that the width of the box must be 0.76 meters. 0.76 meters. Let me actually check for you whether what year, or I mean what question paper is this one from. So I don't know if I had mentioned, but yeah, DBE November 2020. So you can also just check the memo here, and I would encourage you to do the same thing for the other questions as well. But yeah, I hope that you are getting the strategy on how to solve these problems. We had already went through this one. Now I'm going to show you another similar problem to this. I'm not going to solve it in depth, but yeah, just to show you. Oh, well, we tried, guys, we tried. Regarding these remaining questions, I I'll just show you the other questions that I had included here. So this one, it's quite interesting. It's from 2022, I think. Oh, 2021, November 2021. It's another interesting question. So, but it's very similar to the one we have just gone through. After traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close a tap in his garden. He decides to turn around immediately and return home to close it. Let me close that calculator. To close the tap, right? The cost of the water at the rate at which the water is flowing out is 1 rand 60 rands per hour. The cost of petrol is given by this expression, rands per kilometers. So this one is in rands per kilometers, where x is the average speed in kilometers per hour. Another crucial thing to note. So we need to calculate the average speed at which the person must travel home to keep his cost as low as possible. So always, as you read through these questions, you need to make sure that you understand what it is that you need to be optimizing. So in this case, we need to determine his average speed, right, at which he must travel in order to keep his cost as low as possible. It's the cost that, in this case, the cost is the main thing because it needs to be kept as low as possible. So that's what you need to optimize. So you need to find a minimum cost here, you see. So as you can see, unlike other questions that you may have seen here, you are not even asked to show that this is the equation for the cost. You need to work out everything on your own. So yeah, that I think is the tricky part about this question. So let's think about it. This cost, because that's what we need to minimize. So the first thing is to get an equation for the cost. So the cost here, clearly it's going to be given by the cost of the water plus the cost of petrol, right? And we are told that the cost of water is 1 rand 60 rands per hour. So that's the rate per hour, but we want to know the actual value, the money, the actual cost that he needs to pay. So in order to know that, we need to know whether how long is he going to take to close the tap. Right now, he is 20 kilometers away from home. He needs to turn back, so he will have to travel a distance of 20 kilometers, right? So we have a distance here. We have a distance of 20 kilometers. And remember, we are told that x is the average speed in kilometers per hour. So his speed is equal to x in kilometers per hour. So how long is he going to take to get home is the question. So, yep, it seems like we are doing physics in mathematics. So we know that the speed equals to distance over time, right? Equals to distance over time. So we need to solve for the time here because that time will help us in working out whether how much is the water that has already flown out going to cost him. So the time here, it will be given by the distance over the speed if you make, the time the subject of the formula. So that's all that you need to note here. So therefore it means that it will be 20 divided by x. The distance is 20, the speed is x. This will be the time he will take to travel that distance of 20 kilometers as he is rushing back home to close the tap. But the water there that is flowing out is costing him 1 rand 60 for every hour. So it will depend on whether how much time he has taken to get home, whether how much this water that has flown out is going to cost him. So we just simply need to multiply that 160 per hour by the time in hours. Our time is 20 over x, and since the speed is in kilometers per hour and the distance is in kilometers, this time will be in hours. So it's similar to what we're doing. The cost is 1 rand 60 per hour. So per hour is the same as dividing by the hour. So we're dividing this by hour. So once we multiply by our time in hours, then the hour cancels out and we'll get what the actual cost is. That is what we have just done here. So we are done, with his cost for the water. Now we need to consider his cost of petrol. The petrol is that it cost 1.2 plus x over 4,000 rands per kilometers, per kilometer. So he will travel 20 kilometers. Therefore, his cost will be this 1.2 plus x over 4,000 multiplied by 20 kilometers that he will have to travel. You see? And then you just simply need to simplify this. So you do need a calculator there. So what's 1.6 multiplied by 20? That's 32. So this is going to be 32 over x. And then what's 1.2 multiplied by 20? That's 24. So I'm expanding this bracket. And then what's 20 divided by 4,000? 20 divided by 4,000, that's 1 over 200. So here we'll have, it will be x over 200 actually. X over 200. So this is your cost as a function of x. That's your equation for the cost as a function of x. So you want to calculate the average speed at which the person must travel, in order to keep the cost as low as possible. So it means that you need to find x here because the average speed is given by x. So obviously, you know the drill. You'll have to work out the first derivative here, equate it to 0, and then solve for x. But obviously, to do that here, you need to bring this x to the numerator. So it will be x raised -1 plus 24. And then this one is fine. So yeah, as you can see, always once you get the equation, it's very easy, to do the problem from there. So okay, that's it for this one. I think we did not take too much time. So I mean, Obviously, guys, this is not the final answer. As I said, you do need to go on, work out the first derivative here, equate it to 0, and then solve for x. And then you'll get your value of t, which is the average speed at which the person must travel home to keep his cost as low as possible. You'll probably get maybe two values of x, and you'll see which one does it make sense. For an example, the speed should not be negative in this case. It should be positive. So that's what you are going to look for. So since we were a bit fast on this question, we'll just quickly take a look into the other one that we have here. So what's happening here? We've got a wire 12 meters long, and it is cut into two pieces. So our wire is 12 meters long. Now we are chopping it into two pieces. One part is bent to form an equilateral triangle, and the other a square. So we cut the other one to form an equilateral triangle, and we bend one to form a square. And they said a side of the triangle has a length of 2x meters. Hey, let's think about this. So let's think about it. So we had a wire with a length of 12 meters. Now we are cutting this wire into two parts. I'll just say A plus B. We've cut it into two parts, A plus B. Maybe let's say we take, A, and we use it to form this equilateral triangle. We bend it to form an equilateral triangle. And then we use the other one, let's say for an example B, and we form a square. Okay, so what's gonna happen here? Yeah, so they say a side of the triangle has a length of 2x. So each side here is 2x, so that's also going to be 2x, and that's also going to be 2x, because this triangle is equilateral. All the sides are equal, and that's actually good for us. Now they say write down the length of a side of the square in terms of x. Well, in this case, then it means that we're saying that we're using A to form the triangle and using B to form the square. Well, in this case, it means that A, actually here, the length of A is going to be 2x plus 2x plus 2x, which is equal to 6x, right? Because A is what was used in order to form this equilateral triangle. And the perimeter of this equilateral triangle is 6x, which would then be the length of A, of the first piece A. And then we need to work out the second piece B, right? The length that was the length of a side of the square. Okay, well, initially B is not going to be the length. B is obviously just the total length of the second piece, you know, of the wire after it was cut. So B will be 12 minus 6x, right? And now, since this is a square, obviously square has got equal sides. Excuse me. Therefore, this means that each side of the square here, so this is our 9.1. This is our 9.1. Each side of our square, so let's say, yeah, so let's say the length the length of a side of the square, right? It means that it is going to be 12 minus 6x divided by 4, because in order for us to form a square from, the second piece of our wire B, which we now know that it has a length of 12 minus 6x, we need to divide that, equally, each side. Yeah, we need to divide this length equally so that we get a square 4 times, right? So we need to divide all of this by 4. So what is 12 divided by 4? That is 3. And then what is 6 divided by 4? So 6 divided by 4 will be 3 over 2. Okay, my laptop is slow, so that will be 3 over 2. So this will be 3 over 2x. So this would be the length of a side of the square in terms of x. And then 9.2, they say if this square is now used as a base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. Okay. So this is being used as a base of a rectangular prism. Let me try to draw this. So we're taking that square and we are using it to form a base of a prism. It doesn't look like a square. So let me try to do it better. So this will be the base of our rectangular prism, right? And they say this rectangular prism will have a height of 4x. So let's do this. And let's say, yeah, our height is going to be 4x, guys. Okay, so yeah, let's try. Oh, but it doesn't look like a rectangular prism. Let's make it more convincing. I think let me just copy this and paste. Oops, what's this now? Um, Copy, or is there an option to duplicate? Yeah, let's duplicate this, and then I don't know if actually it's gonna do what I want. Okay, not exactly, but I'm just gonna join these like this. Let me just extend these lines like this. You see? Okay, and now let us close our prism. Yeah, so it's overall going to be something like this. It's gonna be something like this. Now, I think this looks more convincing as a rectangular prism. And we know, remember that each side here is 3 minus 3 over 2x. And this is a square. And we are told that the height is 4x. So let's label that, okay? So that is a diagram that's going to help us with 9.2. Now, they say, okay, if now this square is used as a base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. So we are now optimizing what volume? Clearly, we are optimizing volume because we want its maximum. So we need an equation for the volume. So based on what we have, well, firstly, we know that for a rectangular prism like this, the volume will be the length, or let me define it like this. The volume of a prism is always the area of the base area of the base multiplied by the perpendicular height to that area, to that base. So our base here will have an area of length multiplied by length. It's just L squared basically, right? Because the base is a square, so it's gonna be L squared multiplied by H perpendicular. So yeah, as long as we are correct with our 9.1, we're gonna be good here, because now we see that our length on our base, our L squared will be 3 minus 3 over 2x all squared, and then multiplied by the perpendicular height, which is 4x. So this is going to be your equation for the volume. Obviously, you need to expand the brackets and simplify it as much as possible. Okay, and then after that, you know the drill. You need to work out the first derivative, equate it to 0, and that will give you x, right? That will only give you x at the maximum. And after finding that value of x, you will have to sub it in back to your v of x here in order to determine the actual maximum volume of this rectangular prism. So again, you need to expand here. So note that this is all squared. So let me just do it. So this is going to be 9, and then the middle term is 3 multiplied by 3 over 2, and then multiplied by 2. So 3 multiplied by 3 is 9. So this will be 9 over 2, and then multiplied by 2 will cancel that 2. So this is just going to be negative. The middle term here will be negative 9x. Negative 9x, and then the last term, it will be positive 9 over 4 x squared, and then you need to multiply throughout by 4x. Now at least that will be straightforward, right? Just need to multiply throughout by 4x, and then again, as I was saying, after doing that, you need to find v prime of x. And what do you do after that? You make v prime x equal to 0 and solve for x. And then what are you going to do after finding your values of x and you need to choose the right one? You will see based on the signs as well whether which one makes sense. And then you'll just sub in whatever that value of x is to your equation of v and find the maximum volume. So again, I'll just leave this here for you to complete. So now I think this is my very last problem here. It's the DBE November 2023. And yeah, this one I'll just show you. I will not be really going through this one. I think based on what you would have learned at this point from this video, you should be able to do this as well. And then you can just check your answer in the memo, but do comment, down below if there is anything that is unclear after doing so. Otherwise, that is it, guys, from this video. I hope that you have found it helpful. If you have, please make sure that you like this video and you comment, subscribe, to the channel if you haven't done so, and please also share it, with your classmates or anyone that you think would find it helpful. Otherwise, that's it, guys, for this video. All the best. Goodbye.